My name is Ed Cunning. I am the Regional Manager for AEMC Instruments, and today we're going to talk about the 10 kV and 15 kV Megometro series recently introduced by AEMC. Looking up close to the instruments, we can see the functionality and control functions, starting with the output terminals, the plus, minus, and guard channels. These are your high voltage outputs of either 10 or 15 kV, depending upon which model we select. Okay. Next, we have a large graphic display, which will provide both digital input, and ultimately we will actually be able to see a graph on this output. Next, we have the power receptacle. Although this is battery powered device, it can be run off the input voltage while it's being charged, which is a big plus. And we do have the output USB terminal. Okay. We have a 7-position rotary function switch, which allows us to select several different functions and perform unique tests that we require for our output to our given specimen. We have the navigation button switches, which we use to wend our way through the setup menu tree. Next, we have the start-stop button, and this is what will initialize our test, which can either be automatic or we can manually stop it and start it. Okay. And we have our 8 function switches, which allow us to both set up and determine what type of test we want to do, how we want to modify those tests from a timing standpoint, if we want to put in temperature compensation, set alarms for multiple tests where we want to flag an alarm for a reading out of tolerance. Configuration, we use that for the setup function. Display controls what we're seeing. Filter, if we have a noisy test specimen or the atmosphere is such that we are picking up noise, we can smooth that out. And of course the graph, which is one of the key features of the device, allows us to bring up a test that we just performed and review it on the screen itself. Now we can also do that after the fact through our USB back to the Dataview software, which will allow us to also see this test results and then get a hard copy from it. Okay. The display will actually show us 3 different functions or modes, starting with turning it on. We see a backlit display. It is showing immediately the test voltage that we're set at. We have with the input voltage, frequency, current, and other inputs. The next display we will see is while we're conducting a test, and the third display, which we will see, is the test results themselves, where we can actually see the ultimate polarization index, DAR, dielectric discharge, and the actual graph itself. Our 8 function buttons, or control buttons, allow us to program in changes to our test and set up our test. We can put in a temperature coefficient, which will actually alter our reading based on the temperature applied. For multiple tests, we can actually have an alarm function set at an acceptable level and will notify us when we are out of tolerance. Okay. We do have a help screen. We do have a Mem Screen, and Mem allows us to initiate a recording of our test, and it also allows us to bring back up, retrieve a test, and then by hitting the graph button, it allows us to actually see the graph of the curve of our test on the front of the screen. This way we can make informed decisions out at the job site without necessarily having to go back, download the data, and review it on a computer screen. Configuration allows us to set up the time and the duration of the various tests that we select in our function switch. Display allows us to change the various types of information that's being shown in the display both during and after a test. The filter allows us to smooth out the readings in the case of a noisy atmosphere, interference type atmosphere, being picked up, let's say, by the test specimen or the lead length or what have you. And of course, the graph position allows us to bring up a graph shown on the screen. Okay? The key to this whole device is the stop-start button. When we initiate or start a test, we see the red start light flashing, and we know now that we are impressing the high voltage on the test specimen. So it's kind of a warning, and it also tells us that we are in effect activating a test. In the case of a polarization index test or a dielectric absorption that we configured, it will automatically shut itself off. But in the manual test, I would start it as I did earlier, and then I can stop the test now. And at which time I will then go into the display of the test results and provide the various functions. The interface to a computer is a USB connection. However, it is photocoupled. The reason being, we want safety because we have very high voltage present here. We don't want to backfeed this through a computer to, say, some other device. So we simply plug that in, and we have our classic USB connection to our computer. Once we connect our USB port to a computer, now we have the Dataview software that comes with the unit that allows us to bring up the test results and plot a graph, and now allows us to have a hard time. Now for the first time, it allows us to take a graph of, say, an initial test, archive it, and then at a predetermined later time, a year, 2 years, or whatever, conduct a second test and overlay the first test onto the second test onto the first test, and compare and see we are approaching the failure mode of the test specimen. So that's a very unique feature. The guard channel is used when we are in the process of measuring very high insulation values. It is used to bleed off any stray voltages, and also to remove the influence of the operator's hands while he may be touching the test leads going out to the test specimen. In the variable voltage position, I can now get much finer vernier control of the output voltage, starting at the low end at 50 volts for telecommunications, what have you. Then I can increment it in 10 volt increments, clear up to 15 kV in that manner. Again, showing the input voltage, frequency, and what have you. Okay. In the V ramp position, I can determine a liftoff voltage. I can set the ramp time and the ultimate hold voltage. I can determine how long it takes to get there, so we can apply a voltage over a period of time rising up to a predetermined high level point. Okay, and I have 3 of these functions I can store in here automatically. Ramp 1, ramp 2, and ramp 3. In this case, I had different voltages pre-programmed in here to go up to the top of the ramp. The next function is in the step voltage function. I can pre-program 3 different voltage levels, and I can also determine using the config button how long I stay within one step. So this provides us with a ramp, soak, up to 3 levels, and recording that test. This typically would be used in production type facilities whereby we want to impress a voltage on a test specimen and see just where it rolls off without damaging the test specimen. Okay. In the V fixed position, I now have the capability of emulating to some extent a high pot test. That is, I can keep the impressed voltage on the test specimen for any length of time, and I can also control the current. This allows us to go up to 5 milliamps at up to 15,000 volts, which gives us about 75 watts. This again will emulate a high pot test and will probably destroy the test specimen, but it will show us the failure point. Unlike a regular Megometro test, we don't know where the weak spot will be in the test specimen. In the burn mode, we can actually have it identify itself through discoloration, smoke, and heat emanating from the test failure zone or area. Now here is a display of the test real time. It shows us the voltage. It shows us the given resistance of our test specimen, and we get a bar graph or a gas gauge display of also elapsed time into our test. So if we are doing a time test, this will in effect tell us how far we are along into the test, and we will hear a beeping function which tells us that that particular test that's the storage rate that we are putting in for recording. Lastly, we see the display that comes up after the test is complete. It shows us the test result, it shows us the elapsed time of the test, and the automatic calculation of the dielectric absorption, polarization index, and capacitance. So I want to thank you for your time and attention. Again, my name is Ed Coney with AEMC Instruments.